Good morning, everybody. I hope that you guys are having a good start to your Wednesday. We are recording. I'm going to go full screen and share my screen in just a moment. And that's good. That's good. Share screen. Scene. Okay. Before we get started, I have a couple of announcements. One announcement is that next Monday and Wednesday, um, I have some appointments, and so I will not be available during our class meeting. And so what that means is I've got some pre-recorded lectures. These are known as an ed puzzle. These are activities that will be on your Canvas page, that you'll watch, and during that video, there will be questions that you'll be prompted with. So it's sort of like or sorry, let me rephrase this. Um, these lectures will be, or these meetings will be asynchronous. So they will be available to you able by Sunday, the 2nd. Um, and so you'll be able to complete those. Now, with that said, let me go ahead and I'm gonna pull something up. I'm gonna look at it on our Canvas page. Um, just to make sure that I'm looking at you guys's and not mixing yours up with another class's. Um, so you will have quizzes, that, or actually, wait just a second. Sorry. Um, sorry, these will count for the questions in this ed puzzle will count for participation and 2 quizzes. And so basically the way that this is going to be set up is you'll watch the pre-recorded lecture, and a couple of minutes into it, after we talk about a topic, then you'll be prompted with a question. And then that question will be based on what you've already watched. And you'll be able to scrub through the video, so drag and move through the video as you see fit and as you need to. Um, but that's what's going to be happening for next Monday and Wednesday. I will be available if you want to meet through office hours separate from that, but I'm happy that you asked about the due date. Um, if you remember, this next week is actually the week right before spring break. So these need to be done by March 16th at 11 p.m. Because I don't want to have something due on the Sunday or the first Sunday of spring break. And, you might be like, well, I'll do the Monday one before spring break, but then the Wednesday one, I'm gonna watch that at the tail end of spring break. So all of your due dates for stuff that's going on next week will actually not be until March 16th at 11 p.m. So there's a little bit of a lag time there. And just so you know, all of our due dates are always 11 p.m., not 11:59. So 11 p.m. And these will be due March 16th at 11 p.m. Like I said, though, if you want to meet for, I believe I said this, if you want to meet for office hours or if you want to meet to ask me something, talk about something, just send me an email and I'm glad to meet with you. It's just I have some conflicts on those days. So, with that in mind, does anyone have any questions? If you do, you can go ahead and add them to the chat, send a private message. I'll send an announcement out on Sunday detailing like, hey, make sure that you do this. Here's the due dates. Um, and if you want to meet for office hours, just send me an email. Okay, what we are going to be talking about today is sugar metabolism. Specifically, we're talking about the pathway known as glycolysis. So last time what we were talking about was individual sugars, glucose being kind of the most common and important sugar. Now, for glycolysis, this right here is none other than glucose. And glucose is metabolized or is broken down um, with the help of a couple of enzymes. And it's broken down into, and actually, before I go on, add to the chat how many carbons are in this molecule right here. 6. Okay, perfect. So this 6 carbon molecule is pretty much split into two 3 carbon molecules. These two 3 carbon molecules are known as pyruvate. Pyruvate has 1, 2, 3 carbons. And I like to show pyruvate because there's a couple of things that I think that you can recognize about this. For instance, that right there is a carboxyl group. This functional group that I just put a box around, the smaller box, carbon double bonded oxygen, what's that known as? A carbonyl carbon. And then last but not least is our methyl group. So pyruvate is a simple molecule. It's 3 carbons, and it's a carboxyl, a carbonyl, and a methyl group. Those three things are what make up pyruvate. So that's 3 functional groups, pretty easily identified on this. Now, this is the fate of this molecule right here. This 6 carbon sugar, glucose, gets split into those two molecules. Now, this is done in a number of different steps. And in order to understand like the process of glycolysis, it's important to understand what is going into it and why it's being done. Now, glycolysis is done in order to extract energy from substances like glucose. And what I want you guys to know, so these are 2 points that I want you to know so far. Actually, let me take a step back. These are 2 points. These are important points that I want you to be able to do. I want you to be able to identify glucose. I also want you to be able to identify pyruvate. So know those structures, glucose and pyruvate. Now, a big part of understanding glycolysis is understanding why this process is taking place. Well, on the left-hand side of this arrow, I've got kind of an explanation as to what's happening with glycolysis. Like, what is being done in order to get the process moving? And then over here on the right-hand side of my arrow is what's the return? So on the left-hand side, this lists the investment of adenosine triphosphate, inorganic phosphate, ADP, and NAD+. Now, the output of glycolysis, really, it's two things: ATP and NADH. Now, if you've ever taken a biology class or even like sat in on one and someone has mentioned the mitochondria, um, add to the chat yes or no if you've ever heard of the mitochondria or a mitochondria. A Y or an N is fine. Okay. Now, a follow-up to that is, oh, Chris and Stanley. Ah, Chris and Stanley got to my point before I was even going to make it. Okay, Javier, thank you very much. So, the mitochondria is also known as the powerhouse of the cell. And the reason that it's known as the powerhouse of the cell is the mitochondria is where ATP gets produced. So you get a lot of ATP. You generate a lot of ATP, which is sometimes referred to as the currency of a cell or the energy currency of a cell. Um, every time that I like move my fingers or move my arm, what happens in my body is muscles contract and they expand, contract and they expand. And that contraction and expansion requires ATP. So any sort of movement, a gross movement like a gross motor movement, or simply the pumping of my heart requires ATP. And mitochondria and well-developed mitochondria are going to be able to produce a lot of ATP. And so glycolysis is a pathway. So this is a metabolic pathway that generates ATP, but it also generates this NADH. NADH is something that the mitochondria uses. Let me go ahead and add this detail down here. I'm going to put a box around it, then draw an arrow. Used by, I'm going to label it mito or mitochondria to make ATP. So the mitochondria uses NADH to make ATP. So you can kind of think about glycolysis as one thing that it's doing is it's making ATP, which is great. So then different processes in your cell have something that they can do. But then glycolysis is also great because you're making NADH, which can fuel the mitochondria to make more of that ATP. So glycolysis is a process where we're taking 6 carbons of glucose and breaking it into 2 3-carbon molecules so that we can make ATP and make something that we can make more ATP from. Now, over here on the right-hand side, this is the entire process of glycolysis. And if you're looking at that and thinking, oh, what's going on here? Are we gonna have to know this whole thing? No, you're not. What I want you to know about glycolysis is just a couple of the steps. And whenever I say a couple, I really mean 3. I'm not going to say, oh yeah, just a couple. You only have to know 9 of the 10 steps. Okay. Thank you very much for keeping your laptop open. There's 3 steps that I want you guys to know about. And arguably, they're the most important ones. Sorry, I have to send sorry, I can't talk right now. So, glycolysis as this entire pathway is pretty darn intimidating. There's no doubt about that to me. I want you to know the overview of glycolysis. I want you to know that we are going from glucose right here down to pyruvate right here. Okay, so that's the first part. The next thing that I want you to know is there's a total of 3 enzymes that I want you to know what they do. Now, the first of those is right here, the second is right here, and the third is right here. I'm just putting stars by them because in just a second, we're going to go into deeper dive into them. I'll talk about what they do and everything like that. So I want you to have the big picture of glucose to pyruvate. And what are we getting out of it and what are we putting into it? So if you're looking at this slide, oh, I'll take a step back. If you're looking at this slide and thinking, okay, he told us we need to be able to identify the structure of glucose and of pyruvate. Yeah, that's true. Then I think that it's worthwhile to look at um, the other parts of this step, of this slide, and think, what else does he want us to know? Let me tell you, this investment right here, that to me looks like a really good select all that are correct statement or question. You know, something like select all things invested in glycolysis. Because that's a list. ATP, PI, ADP, NAD+. Then I can throw on there like carbon dioxide, potassium, bananas. Um, and bananas, I would not want you to think like, is that a trick question? No, it would not be a trick question. Okay. So that's a good way to view this sort of information. Like that's one way that I think that would be helpful for you to kind of consider the information that you're presented. Okay. This is the big picture. Glucose to pyruvate, we got three enzymes that I want you to be familiar with. Before we get to those three enzymes, I want you to think about the phases. There's two phases in glycolysis. The first phase is what's known as your investment phase. It's basically the top half of the pathway where we go from glucose down to GAP. And I am completely fine with understanding, okay, acronyms. So another way that might be a little bit more clear is that when we go from the pathway is glycolysis. We're going from glucose. I always like to say glycolysis. I think both of those terms are Greek. Um, Glyco meaning like a sugar, and then lysis meaning to break or to cut. So we go from glucose in this investment phase. Put a box around that because this is our investment phase where we take glucose, and I'm going to go through each one of the steps. Do you have to know all these steps? No, you don't. Glucose is going to be what's known as phosphorylated. So we'll take this molecule right here. The molecule that I have a circle around right now, does it have a phosphate on it at all? And you might have to, let me zoom in a little bit. The molecule, the red circle around it, does it have a P for a phosphate or a phosphorus? No, it doesn't. But then when you look at the next molecule, I gotta zoom back out a tad. Too far. Nope, there we go. Our next molecule. Notice the difference between, oh, rats. Joel, come on, computer. Why'd you do that to me? Okay, we go from glucose to a compound known as glucose 6-phosphate. That is adding a phosphate group onto glucose. So that is where ATP becomes ADP. We're transferring a phosphate from ATP onto glucose to make glucose 6-phosphate. Then look at this down here. I want you to look at these two molecules that I have. Oh, what on earth was that? Let me try that again. These two molecules that I have a big box around. Oh, that kind of helps. Okay, there we go. These two molecules that I have a big box around. Glucose to fructose. Glucose 6-phosphate to fructose 6-phosphate. Look at, and I'll give you a second to look at those two molecules. And let's go ahead and start with carbon number 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. I'll give you a little bit of a notice. These two molecules, glucose and fructose, glucose 6-phosphate and fructose 6-phosphate, they both have a phosphorus on carbon number 6. They also have every single other atom where they all have otherwise identical atoms. So if they have the same number and identity of atoms, what does that make these two molecules? They're isomers of one another. So basically, step one in glycolysis is one, add phos. Step two, rearrange. Step three, add phos, where we're going from fructose 6-phosphate to fructose 1,6-bisphosphate. Then step four, we're going to take our 6-carbon molecule right here. What on earth? My tablet's on the fritz. That means I'm going to have to throw it away soon because it's a piece of junk. Fructose 1,6-bisphosphate. Well, that's a molecule that it's just, it's just had a phosphate added to it. It's 6 carbons. And then it's broken into 2 3-carbon molecules. One of them is glyceraldehyde 3-phosphate. The other is a compound known as dihydroxyacetone phosphate. That dihydroxyacetone phosphate gets rearranged to make glyceraldehyde 3-phosphate. Now, if you're looking at this and you're thinking, okay, you said we had to know 3 reactions. You've now described like 5. I have. 2 of the 3 reactions that you need to know. The first is step 1. The second is step 3. What I want you to know, and I'm going to erase all of this over here. What do I want you to know about these enzymes? First, I want you to know the input. So like the input sugar. And ATP. So the difference between these two enzymes is, well, for number 1, it's glucose, and you add ATP to it. For the next reaction, it's fructose 6-phosphate, and you add ATP to it. Okay. The second thing that I want you to know is the name of the enzyme that catalyzes the reaction. Well, it's hexokinase and it's phosphofructokinase. Then third is going to be, our third enzyme is, just a second, I'm sorry, I've got to, the third thing that I want you to know about this is the output. What is the product that's generated? The product and ADP. Those are the things that I want you to know about these 2 enzymes, and a third one's coming soon. Okay, so our first 2 enzymes that we need to know are in the investment phase of glycolysis. Now, there's the investment phase, but then after that, there's the return phase, basically where, we kind of get back what we put into it. So in our investment phase, we spent ATP, and in our return phase, that's where we get ATP back. But what I want you to know about this is our return phase. Okay, let's try that. Oh, that's not what it is. Sorry, I'm having a computer issue right now. No, that's not what I want. Okay. Our return phase. What I want you to notice about the return phase is we invest 2 NAD+. And what we get is 2 NADH. because we have two 3-carbon molecules, two 3-carbon glyceraldehyde 3-phosphate molecules. Then what we're going to do, we're going to invest 2 ADP. That's at our first point. So we invest 2 NAD plus. We also invest inorganic phosphate or PI. We're going to return 2 NADH. Then we're going to invest 2 NAD or 2 ADP right here. And whenever we do that, what do we get back? We get ATP back. So at this point in time, this this step right here, when you think about like the accounting of the ATP, are we good right now? Have we gotten back what we put into it? Are we at zero? Answer in the chat. Are we at zero ATP now? Or are we at a net zero ATP? We think about our investment phase, we spent 2 ATP. And now, how many ATP have we gotten back? 2. So we're at zero. We're even. Okay. But then we're going to continue on. And what are we going to get out of it? In this last step, which is the last one that I want you to know, we're going to get 2 more ATP. So this last step is the third enzyme that I want you to know about. Now, when you think about these different steps and you think about this whole process, there's a couple of different ways you can look at this information. One way is, what is the total number of ATP generated? What's your total number of ATP that are generated in glycolysis in this entire pathway? We 4. It's 4. And I'm sorry, let me add a little bit of a detail here. This pathway can be a little bit confusing. And the reason that it's a little bit confusing is because glyceraldehyde 3-phosphate, that's a 3-carbon molecule. That is the product from where we took our 6-carbon molecule and split it into 2. So now we've got kind of, it's like we have this pathway running twice in complete parallel. So when you look at this right here and it says ATP, what that really means is that you've got 2 ATP because from this input and this output, you've generated 1 ATP, but that's happening 2 times. Does that make sense? So we generated, or we have generated a total of 4 ATP. But when we do the accounting and say, well, what's our profit? Well, our profit is only 2 ATP. Why is that? Well, because we had our initial investment of 2 ATP. So we invested 2 ATP, we got 4 back, but then we count out or discount those 2 ATP, those other 2 ATP. Okay. So your big picture of all of this is glucose goes through a series of steps. You invest 80 ATP, you get back ADP, but then you invest more ADP, you get ATP, you get NADH. Now, the 3 big enzymes that I want you to notice and that I want you to pay the most attention to, I'm going to circle the enzyme name. Hexokinase, phosphofructokinase, and pyruvate kinase. Now, look at the arrows that are next to hexokinase, phosphofructokinase, and pyruvate kinase. Then look at the arrows in all of the other steps in glycolysis. Do you notice anything about any difference of those arrows? I'm talking about the black arrows. And let me put it this way. The arrow next to pyruvate kinase, aha, they're going both ways. Enolase, for instance, the second to last step. Well, that's got arrows that go both ways. We talked about those arrows that go in both directions when we talked about enzymes. What is an arrow that goes both ways? What does that mean in terms of reactants and products? Yeah, it's reversible. Okay, so if an arrow that goes both ways is indicating a reversible reaction, what would you say about this? The reaction catalyzed by hexokinase. Perfect. It's not reversible. So these three enzymes, I selected these three because these are what are known as the three irreversible enzymes of glycolysis. The things that I want you to know, like I said on the previous slide, I want you to know what sugar is input. I also want you to know the name of the enzyme. And I want you to know the output of them. So your three irreversible enzymes are the ones that I want you to know. Now, there is one small detail that I'm going to add about phosphofructokinase. This is what is known as the first committed step of glycolysis. So, if I like college football and um I watch that from time to time, and there's always moments where someone's they sign their national letter of intent, they commit to a particular school. And typically what that means is, when someone commits to go play football at um Auburn, I don't know why I'm thinking of Auburn. I could just say Texas State because that's where we are. But I said Auburn, so I'm committed to saying Auburn as my example. When someone commits to and they sign off, I'm going to go play at Auburn, what do you think that means for where they're going to play football? They're probably going to go play football at Auburn. Okay. Now, whenever I say this enzyme is the first committed step of glycolysis, what do you think that means for the product that's generated by this enzyme? Add it to the chat. What do you think that means? And if somebody says it's going to Auburn, I like it, Chris. The product of this fructose 1,6-bisphosphate, not only can it not be reversed, but this is committed to going basically all the way through to pyruvate. Now, I want to compare and contrast that with glucose 6-phosphate over here. So hexokinase is an irreversible step, but it's not a committed step. It's not committed to going through glycolysis. So what that means is that glucose 6-phosphate has other uses. Whenever that glucose 6-phosphate gets made, well, it's not going to go back to glucose, but it can be used for a number of different things. For example, it could be used sugar storage, as is the case with, does anyone know the major sugar storage molecule in your body? Or the compound where sugars are packed up in your body? Glycogen. Perfect. Glucose 6-phosphate doesn't have to go all the way through and be broken down into pyruvate. It might be made and then shifted off to be stored as a part of glycogen. Okay. Now, here's our first enzyme, and I show hexokinase. I show this little arrow, but just kind of ignore that. because this is our irreversible step. Hexokinase is taking glucose and it's taking a phosphate off of ATP and adding it on to carbon number 6 to make glucose 6 phosphate. I'm showing you these structures because I want you to be able to identify them. Glucose 6 phosphate, well, it's a ring that is 1, 2, 3, 4, 5, 6. There's 6 atoms that make up that ring. That's our first irreversible step. It's not the first committed step, but it is the first irreversible step. Our next irreversible step, which is our first committed step. I'm going to add this first. Fructose 6 phosphate. Fructose 6 phosphate is an isomer of glucose 6 phosphate. Fructose 6 phosphate gets a phosphate transferred from ATP onto fructose 6 phosphate, making fructose 1,6 bisphosphate. This is our first committed step. And this fructose 6 phosphate is, well, it's going to go on to be processed to be broken down into pyruvate. Our last step is an enzyme known as pyruvate kinase. Pyruvate kinase, we're going to invest ADP. We're going to transfer this phosphate off of phosphoenol pyruvate to make ATP and to make pyruvate. So, what are some things that are worth recognizing about these different enzymes? The first thing is they're all irreversible enzymes. The next thing is that in addition to being irreversible enzymes, well, sure. To this slide, Chris. I'll just let me know whenever you're ready to move on. Okay, cool. So this is our first committed step. We make fructose 6,1,6 bisphosphate. That's going to go on to be processed all the way down into pyruvate. This step right here, this is our very last step. It's worth noting that it's our last step and knowing that it's our last step because our product is our final product of this entire pathway. We've got ATP, 3 carbons. Pyruvate is 3 carbons long. We input glucose, which is a 6 carbon long molecule. So basically, this whole reaction is happening 2x, 2 times, because 6 carbons are split into 2 3 carbon molecules, and we're going to get ATP out of it. So this, this molecule, phosphoenol pyruvate, is going to transfer a phosphate onto ADP to make ATP. We're going to also get out of that pyruvate. Remembering that pyruvate has a carbonyl carbon, or carboxyl group, a carbonyl, and a methyl group. Now, with that in mind, that's what there is to it. Now, what I want you to know in addition to those enzymes is I want you to know about, well, what do we get out of this? When we invest 1 glucose, we're going to get a net of 2 ATP and 2 NADH. Why net? Well, because we invested 2 and we get 4 out. So 2 of them cancel 2 of those products. Now, with that in mind, it's good for you to think about first ATP invested, the second ATP invested. So that's where our second is invested. First 2 returned. Second 2 returned. Now, one of the questions that I like to ask is, well, a straightforward question. If you invested 100 glucose, how many ATP would you get? Would you make? Well, 100 glucose. How many ATP would you make? Add it to the chat. Ooh, I like it. Chris, great job. Great job. And you know what? You pointed out, maybe intentionally, unintentionally, um, I need to fix this question. I would say 100 glucose. What is your net ATP yield? That's using more technical terminology, and it's specifically asking about what I'm getting. How much energy would this process be? Like, how much would 2 net ATP really be for? Oh, that's a fantastic question. Yeah, you're absolutely right. It's 200. Okay, so Javion's question, how much energy would this process be? Like, how much would you get from 2 net ATP? Okay, I'm happy that you asked that because to be completely honest with you, a single glucose molecule, actually, let me take it back for a second. Glucose, your body is going to take glucose and break it all the way down to CO2. Now, let me ask you this question. Is pyruvate CO2? And actually, glucose will be broken down into 6 CO2 molecules. So, is pyruvate CO2? No, it's not. You're absolutely right. It's not CO2. So, what does that mean for like to totally break this pyruvate down? That's right, Stanley. What do you think that means for that pyruvate? Is there more work to be done? Yeah, there's quite a few more steps. We got to break this down even further. Um, so there's additional paths or additional steps, and I think that let me think real quick. I think one glucose gets you like I'll say somewhere in the order of 30 ATP total. When you take one glucose and you break it all the way down to CO2, you're going to get like 30 ATP. Okay. Now, thinking about that, what I've got here is a 1919 classic American root beer, and this has 57 grams of carbohydrates. I'll just say 57 grams of sugar. That would be approximately, I'll say 0.3 moles of sugar. Okay, answer me if you're still with me. Or just say, yeah, I'm still with you. Okay, cool, cool. Um, okay, so we got zero point 0.3 moles of sugar, one molecule of sugar. And in this case, I'm imagining that this is sweetened with nothing but glucose. Chances are slim that it is. It's sweetened with high fructose corn syrup. I'm pretty certain of that. Um, yeah. But one molecule of a sugar. Okay, so if we have that's I want to highlight that point. Um, 0.3 moles of sugar. In order to figure out that we would multiply zero point 0.3 or how many molecules of sugar there are. Well, we would say zero point 0.3 moles of sugar times, yep, 6.02 times 10 to the 23rd um, molecules of sugar. So that would put us at like, looking at my calculator here, zero point 0.3 times. So we're looking at 100. Well, actually, let me go ahead and we're looking at approximately, sorry, just a second. It's the same number, zero. That's about two. I'm just going to round here. 2 times 10 to the 23rd molecules sugar. So one molecule of sugar gets us 30 ATP. This right here is going to get me trillions, billions of molecules of ATP. Now, your question of like, I think that your question is really just like, would I see breaking down a single CO2 or whenever I move my arm, is that representing like one molecule of glucose or is it 50 molecules of glucose? And the answer to that question is it's like hundreds of thousands, if not millions, of molecules of glucose. So, like a single ATP molecule, or to get one muscle fiber to like contract and expand, that would take hundreds of ATP molecules. Yeah, exactly. And I'm sorry for going on kind of a roundabout, like, oh, I should do this, and then this, and then this, and oh, I'm drinking root beer. That is my ADHD. Um, so one ATP is basically nothing, kind of. Um, okay, okay, thank you. Good. So yeah, one ATP really is not going to do a whole lot. Now, with that said, I think that it's really easy to think about energy in terms of like, oh, well, I'm going to go lift up a couch. But you know, is anyone familiar with like a BMR, like your body's basal metabolic rate? That's like the amount of energy that your body is consuming if you sat all day long like this. Is your body burning energy? It absolutely is. So when you go and lift up a couch, is your body burning more energy? It is. Yes. Yeah. So total daily energy expenditure. Absolutely. Sorry, I was confused by tree. Thank you very much, Stanley, for clarifying though. So one ATP isn't going to do a whole lot, but we're not, you're not going to go to the grocery store and be like, I need 3 ATP. Instead, you're getting something with calories that will give you millions upon millions of ATP molecules because it has millions upon billions of glucose molecules. Okay, so what I want you to be able to do with this information in terms of the ATP yield is I want you to know this right here and how it relates to a question like this right here. Now, where it gets a little bit tricky, and this is where it's helpful to remember the total number of ATP that can be generated, is what if you consumed food that had nothing but fructose 6 phosphate? So if you decided that, hey, I found a food source that has F6P as my input, What are you doing then in terms of this pathway? And to qualify and revise my question there, are you skipping a step? Yeah, you're skipping this initial investment step. And when you skip that initial investment step, then your investment. So let me, I'm going to go ahead and erase some of this stuff. You'd net three, not two. That's absolutely all right, Chris. If you consumed only F6P, you would get, or you'd return, say return more ATP than if you consumed glucose. Does that does that scenario make sense? Let me erase this. And just let me give you a little bit of a spoiler. Um, that's not really something that you can, oh, I'm going to get this type of flour, and then I'm only going to be having fructose 6 phosphate. No, I'm just saying, like, think about this pathway and what would happen if you jumped in at this stage or at this stage? Can I get a thumbs up or a yeah in the chat if that scenario makes sense? Okay. Okay, cool. Well, this is all that I've got for today. We talked about the yield, the ATP yield. We talked about the three major enzymes and the little details that I want you to know about those enzymes. The overview of the entire pathway and kind of the takeaway of what is glucose metabolism and what is sugar metabolism in general. Um, like I said, next week, Monday and Wednesday, those will be asynchronous. I'll send out an announcement on Sunday with like a detailed list of here's where this is, here's where this is, here's what you need to do by this date. If you would like to meet for office hours, please don't hesitate to contact me, and I'm glad to meet with you. And other than that, though, I hope you have a great day. And I will see you guys after spring break. So have a good spring break if I don't talk to you before then. I'm going to go ahead and stop my recording and